Okay, example 6. The conjecture is if a number is a multiple of 9, I should say then the sum of the numbers, the sum of its digits is a multiple of 9. So, let's look through this. This one here is written as an if-then statement, which is a more common way to actually look at conjectures. The ones we saw before were more categorical statements. They give you a category and said something. But if-then statements say if something happens, then something else will happen. I'll give you a specific example that happened to me yesterday. I told the golfers, if it's raining at 3:45, then we will not have golf practice. It was raining and we didn't have golf practice. Right? There's an if-then statement. That was a true conjecture there. It was cold and wet, and it's just not good golfing weather, so we didn't do it. But anyway, this is saying if we have a number that's a multiple of 9. Okay, so let's take a look at what multiples of 9 look like. Do you guys know what multiples of 9 are?
Yeah.
Count by what?
9.
Count by 9, right? So if we're counting by 9, we got 9, and then 18, and then 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, 117, 126, 135, 144, 153, 162, 171, 180, 189, 198, 207. Yeah, we can just go on. Those are all multiples of 9, right? The conjecture is if you're on that list, it says so anytime they say conjecture, it means for everything that fits the description. So that list goes on for a while, right? And it's saying that every number on that list, if we have a number on that list, then the other fact is the sum of its digits is a multiple of 9. Yeah, that's real easy to test, right? Sum of digits means we add up the digits. 9. 1 plus 8 is 9. 2 plus 7, 9. 3 plus 6, 9. 4 plus 5, 9. 5 plus 4, 9. 6 plus 3, 9. 7 plus 2, 9. 8 plus 1, 9. 9 plus 0, 9. 9 plus 9, 18, which divides by 9, right? 18 is on the list, right? 108, 1 plus 1, 0 plus 8, 9. 117, 9. 126, 9. 135, 9, and so on. Most of them add up to 9. All right? I could get really crazy. Let's get a calculator out for this one. Any multiple of 9, right? So if I take any number, Blaine, pick a number, like give me 5 digits.
6, 8.
Oh, hang on. I got to turn my highlighter off. All right, 6, 8.
3, 4, 5.
3, 4, 5. If I take that times 9, that's a multiple of 9, right? So that number, the digit should add up to a multiple of 9. Let's add them up. 6 plus 1 is 7, plus 5 is 12, plus 1 is 13, plus 5 is 18. That's a multiple of 9. Seems pretty true, right? Usually, if you can't find a counterexample rather quickly, it probably doesn't have a counterexample. Because again, when there's a counterexample, it's false. If it's false, there's millions of things that are false. So usually, it's not that hard to find a counterexample. So I got a long list there. None of them make this false. So I would assume this to be true. And again, if it's true, give me some examples. Give me a few examples. That right there would be sufficient. 9, 18, 27. You could also go with Blaine's, what is it, 615,105. If you really wanted to, but I'd go with the small ones. They're usually right. So again, they're either true or they're false. If they're true, say they're true and show a couple examples why. If they're false, find at least one, if not more, one sufficient to prove it to be false. That's all you're doing today is homework. And I might have thrown in a few problems from day one. Skills also patterns.